I'm building a low-cost robot tentacle arm, a type that is more formally known as a continuum arm. This type of movement is the goal. The bigger idea behind my robotics project is to be able to do anything from anywhere. We can currently do knowledge-based work from anywhere, but our ability to do physical work remotely is more limited. So how does this thing work? So the operation is, you've got your motors down here, and tendon would be pulled, then it moves the arm. And so with 3 points, the idea is they're going to move to any point along its curve. A while back, I did kind of a video motion study and did some analysis on it to see the pull distance related to the motion of the arm. That I still need to do a more rigorous study. Let's take a look at the current control software. This is a very rudimentary start, as the movement can be smoothed out by accelerating and deaccelerating the motors along sine wave curves, or sinusoidal movement, so that the motors speed up and down more smoothly rather than abrupt starts and stops. I put a library called Pyformata on the Arduino that enables me to send commands via Python and don't have to manually re-upload the code every time I make an update. I put together a Jyupter notebook to send commands over to the control boards. Going forward, I want to use a web-based interface for the control software, and that can be worked on more later. In the notebook, there's the initial includes for Pyformata, utility imports, and IPython-related imports. The Arduino COM port is specified. The CNC board pins are set up. The generalized basic stepper motor function. The function for moving multiple steppers by interlacing their movement. The IPython interface setup, defining what happens when buttons are clicked. And a basic motor movement interface that allows controlling the motors together or individually. You can find a link to the open source code in the video description area if you are interested. NEMA 17 stepper motors that have 200 steps. That is, the motor rotation is divided into 200 steps along the turn radius, allowing for a good amount of precision control. At the moment, there are wooden makeshift spools, dowel segments for spooling the tendon cables, but in the future I'll replace these with proper pulleys at some point. The control electronics is this CNC Arduino shield that has the stepper drivers on board. So on the top you have the shield, and underneath the Arduino, and inside this 3D printed box that I modeled and put together. Well, we've got the arm that has a flexible tube for its spine, and we've got some cables that are tendons that go through the holes in some 3D printed disc. The cables are just made out of fishing line. The vertebrae disc are 3D printed, PLA, and hot glued to the spine. The frame is aluminum extrusion and aluminum plates. So the extrusion is pretty nice stuff to work with. A bit more expensive than, say, if you were just to cut it from raw stock, but pretty nice to have the grooves and to be able to position your bars anywhere you want along the surface. Rather than simply thinking about robots as people replacements, we can think of them as effort multipliers. They can enable one person to do many tasks or many of the same task at the same time. Complex tasks can be simplified through expert systems, where the more complicated expert knowledge is contained within the software, and then the user can manage and choose individual actions without having to automate the whole system from end to end. Breaking things up into smaller pieces, micro AI, that has more tasks, and user assisting focused can be a more practical way to deploy robotics to multiply effort and create more value per person. These things done well could result in near universal employment and the democratization of work, where manufacturing and services could be done locally and managed remotely. One issue with good robot arms is that they are expensive, but this doesn't need to be the case. It doesn't have to be all or nothing. Hopefully this gap between toy and industrial can be bridged to create capable arms that are not in the thousands and perhaps not even the hundreds or very many hundreds. The current prototype arm that I'm working on is pretty inexpensive. If all goes well, this is just the beginning of exploring cool concepts in robotics, AI, remote work, and reaching new heights of what is truly possible.